All right, so let's continue the discussion on rolling and sliding. Now, if you see, there are two parts shown in the graph. One part is where the frictional force exists. When the frictional force is existing in the part one of the motion, you have an increasing angular velocity and a decreasing, linear velocity. So there's a deceleration, but angularly there is alpha, which is angular acceleration, which is increasing the angular velocity. And at some point, part two of the motion, the frictional force disappears and the velocity no longer changes. The angular velocity also no longer changes. Now the question is, why does the frictional force disappear in part two of the motion? Now the reason is that when the velocity becomes equal to r omega, which is the linear part of the velocity, becomes equal to the vector, which is the v created by rotational motion. At that point, the relative motion between the ground and the rolling sphere disappears. There is no rolling, there is no relative motion that exists. And we must understand that friction can only occur if there is a relative motion. So if the point which is touching the ground has attained zero velocity because of opposing nature of linear velocity and velocity created by rotational motion, you cannot have any frictional force, and hence the friction becomes absent, and you see this part two of the motion. Thank you.